Welcome to 11.5. In this section we're going to talk about volumes of pyramids and cones. To start out with, we're going to talk about theorem 11.8. To find the volume of a pyramid, we take 1/3 of the product of the area of the base and the height of the pyramid. So when we look at the formula here, we've got capital B is the area of the base, H is the height, and we need to multiply that by 1/3 to get the volume. For our first problem, we've got the Great Pyramid of Giza is the largest of the original 7 wonders of the world. The pyramid originally had the dimensions shown below. What is the approximate volume of the Great Pyramid? So as you can see here, we've got a height of 485 feet, and we've got a side length of 755.5 feet. That is also going to be this side since they are squares. So our volume formula is going to be 1/2. The area of our base, since it's a square, is going to be 755.5 squared, and then times our height of 485. If I type that into my calculator, I get 92,276,140.42, and our label is cubic feet. Now we're given a pyramid that's also a square pyramid, so all of these sides are going to be the same. They're all going to be 18. But now we're given the slant height. So what we need to do now is we need to take out this right triangle in here. So if I do that, I've got my slant height of 15. I've got half of a side length here, so that's going to be 9. And I need to find my height of x. Now since I drew it from the point, it's going to make a 90-degree angle, so this is a right triangle. I can use the Pythagorean theorem. So I can take 15 squared minus 9 squared to get x squared, which means that x squared is going to be 144, which gives me my height of 12. So I've got a height of 12. So in my volume here, I do 1/3. The area of my base, again it's a square, so my area is going to be 18 squared times 12. And when I type that in, I get a volume of 1296 cubic yards. Theorem 11.9, volume of a cone. The volume formula for a cone is the exact same for a pyramid. We take 1/3 times the area of the base times the height of the cone. Now the only difference here is with a cone, our base is circular, so to find the area of our base, I'm going to need to do pi r squared. So that's the only difference between a cone and a pyramid. So our example here, about how many cubic centimeters of water does the paper drinking cup hold? Okay, so if I've got a diameter of 8, that means that half of that, which would be my radius, is going to be 4. So the area of my base is going to be pi times 4 squared, which would be 16 pi. Now, I'm also given 11 as a slant height, so I need to find the height. Well, I've got on my right triangle here, I've got a hypotenuse of 11, a side length of 4. I can do subtraction. Okay. I get that x squared is 105, and the square root of that, I get that x is roughly 10.2. So that's going to be my height. So when I do my volume, I'm going to do 1/3 times the area of my base, which is 16 pi, times my height, which is about 10.2. And if I type that in, I get that the volume is about 170.9 cubic centimeters. Okay, so now we have an oblique cone, which means that the tip of the cone is not over the center of the base, but that doesn't matter. I'm still going to use the same exact formula that I did below. So if I am given a diameter of 16, that means that the radius is 8. So the area of my base, or capital B, is going to be pi times 8 squared, which is 64 pi. And now I know my height, because that's the height right here, it's 15. So my volume is going to be 1/3 times the area of my base times my height. So 1/3 times 64 pi times 15. Okay, now they want it first in terms of pi. So if I do that, I get that my volume is 320 pi cubic inches. They also wanted it rounded to the nearest cubic inch. So if I type in 320 times pi, I get about 1005.3, which would round to 1005 cubic inches. So we would have both of those as our answers.